Hello, everyone, and welcome to this joint meetup with GDG Cloud Bangalore and Cloud Native Bangalore. Thank you all for tuning in. And for today, we have a very interesting session around distributed tracing, which is gaining importance to help the DevOps practices like observability since microservices are becoming mainstream. So we have two speakers for today's session, Pavol Loffay and Jayesh Ahire. Pavol Loffay is a software engineer at Traceable.ai working on API observability for cloud-native applications. He is the maintainer of Hypertrace, Jaeger, and OpenTracing projects. Jayesh is a founding engineer at Traceable.ai, where he primarily works on OSS project Hypertrace. Jayesh is the first AWS ML hero in India and also the organizer of AWS User Group, Elastic User Group, TensorFlow, and the Microsoft AI community in India. So without further ado, over to you, Pavol and Jayesh. Pleasure having you here and take it away.
Thank you.
Thank you.
How do you want to start?
I think you should start, and then I will take it from my intro.
Okay, you can just share your screen then. Cool. So thanks Unsi for introduction, and yes, welcome everyone to Introduction to Distributed Tracing and Hypertrace meetup. So we will discuss about what is observability, what is distributed tracing, and how Hypertrace is helping us to incorporate distributed tracing in real world. So next slide. As Unsi said, I'm Jayesh Highway and I'm founding engineer at Traceable.ai. I primarily work on Hypertrace and I'm also AWS Machine Learning Hero and PDO Champion. If you have something, and I do my research on distributed neural computers. So if you want to discuss something around that, you can find me on Twitter at Jayesh_Highway1. Pavol, you can continue from here, I guess. Cool.
Yes. Okay. So hello, everybody. My name is Pavol Loffay. I'm software engineer at Traceable.ai. I work on the data collection in the Hypertrace project. And before joining Traceable, I was at Red Hat working on different open source observability related projects. I was maintainer of Jaeger, OpenTracing, and also contributor to OpenTelemetry, Java SDK, but also OpenTelemetry collector. So on today's agenda, we'll start with discussing how we can understand deep systems, because this is the problem that we have today with very complex architectures. And then I will try to make introduction how we actually monitor or how we used to monitor these systems with telemetry data, what kind of telemetry data we can collect from the environment. And this will lead us to distributed tracing. I will explain you how tracing works and why is it better than the traditional telemetry signals like metrics and logs. And then we will do Hypertrace demos. So you will see how Hypertrace is used kind of in production to monitor a microservice-based application. And last but not least, we'll mention how you can engage into Hypertrace community and how we can use Hypertrace in your organization. So understanding deep systems. So the problem what we have today is that we write very complicated code. And the complicated code is very hard to understand. And usually what happens when you are loading, it might be a simple web page or doing something in your mobile application. What happens behind the scenes in the backend is that to process this request usually involves hitting maybe dozens or hundreds of microservices. And once all these microservices, they do something, they process the data, and the response is returned to the user. And it's very hard to understand what actually happens with this request, because we have to understand end-to-end what happened with the request. It's not anymore, feasible to just have a look at a single service and understand what is happening in a single service. With the complex applications and distributed applications, we have to understand what happened end to end. So when speaking about complex applications, on this screen we see a screenshot from Jaeger. Jaeger is a distributed tracing system, and each node represents a microservice. And this is taken from the Uber architecture. So it basically shows all the Uber microservices. And so, for example, when you are ordering a ride, what happens is a request, enters the environment, and it hits the first service, then it hits the second service, and so on. It continues, until the full response is ready to be sent to the user. And what is important here to kind of mention is that request goes through multiple services, and the problem is that it goes very deep into the environment. And sometimes, going deeper is much worse than going wide, because when it goes deep and then it also goes wide in some deeper parts of your architecture, it makes it very hard to understand, the full story of a request. So when we look at other, complex architectures, on this slide we see Amazon.com. And it's almost impossible to understand this architecture. There are so many, nodes or application deployed that you cannot tell from, looking at the architecture diagram what is actually happening in such environment. When you look at Netflix, it's a similar story. Like, there are so many services that it's impossible to understand it. So we have to now understand the systems by use cases or by, the business API what we provide. And each of these APIs, they kind of show you a story, what happens for this API. So they show you like what kind of microservices serve this API. So we have to understand the story for each kind of API what we expose to the internet. And traditionally, we used to monitor the systems by using metrics and logs. These systems traditionally emit these two telemetry signals. And that's great. I mean, with metrics, we still have to collect metrics because they provide kind of immediate feedback from the environment, what is happening. So for example, if your application is running out of memory, you will see that immediately in the metrics that something wrong is happening. But the problem is you don't know what is happening. There is no context in metrics. On the other hand, in the logs, there is a lot of context. So you go from metrics to logs, and now in the logs, you see a lot of information. And the problem is that service that is emitting logs is emitting logs for every request. And if there are multiple concurrent requests, which there usually are, it's very hard to correlate the logs for a single request. And now imagine you would have to correlate those logs through multiple microservices, because the request goes to multiple microservices as it serves this transaction. So it's very hard to correlate those logs, even within a single service, but also within multiple services. The other problem with logs is that different services, they emit different logs. So for the same event in your system, let's say event is a serving HTTP request, each service logs different information. So some might have logged the full URL, some service might log just the HTTP path, and so on. So even though you correlate those logs, it's hard to understand them because there is no data semantics defined across multiple services, because multiple services are usually written in different languages or in a single language, but they use different RPC frameworks which use logging differently. So this leads us to how we should solve this problem, right? With not able to correlate the information, but also the fact that different services and frameworks emit different data. And the solution to this is distributed tracing. Distributed tracing at a high level basically allows you to tell stories about the requests or about transactions that go through multiple processes or multiple services in your environment. The foundation for distributed tracing is the context propagation. So basically, when a transaction goes throughout your system, the context is being propagated, is attached to this transaction, and it's being propagated to all the services that handle this transaction. And because of this context, we're able to correlate all the events from the microservices that emit some telemetry data, and we are able to say like what kind of events happened and in which order. And last but very important point here is that in tracing, what usually is enforced is that all these services, they emit the same events. So if tracing instrumentation is modeling HTTP request invocation, it will emit the same kind of metadata in all different languages and RPC frameworks. So it makes it very easy to understand, the invocation in a polyglot environments. So let's have a look more deeply into distributed tracing. So there are basically three concepts. There are, let's say, two data structures and one more broader concept. Data structure is a span and trace. And then there is distributed context, which is, I will explain it in a bit. So on this slide, we see two parts. The top part, there is a user and some environment in the cloud. And on the bottom, there is a diagram from the tracing system. So let's talk about the user and the cloud. So when a user, does something, let's say in a mobile application, the mobile application will create a request that goes somewhere in the cloud, right? It enters the cloud, it goes to load balancer, and then it hits the first microservice, then the second microservice, and so on, until the full response is kind of assembled and returned back to the user. Where tracing, takes place usually is the first microservice in the environment. And what tracing does basically, as the request enters the microservice, the tracing will create a unique random ID called trace ID that is attached to this request. And it will also kind of model all the invocations in the system. So for example, in the first microservice, it processes the request. So it will create an object called span, which models this invocation. Then as the invocation continues to the second service, the tracing system will create a second span, a child span of the previous span that also models the invocation in the second service, and so on. And all these spans, they have the context in them, which was created when the request first entered the first microservice. And so later on, once the tracing emits all those events to the tracing infrastructure, the tracing system can correlate all these events together and show you something like this diagram, saying like, this was the first operation, which is the parent span, and then there was a second operation, which is the child of the parent span. And you clearly see, the relationships between operation in a system. An operation can be anything. It can be HTTP request invocation, or it can be internal method invocation. Let's say in Java, it can be like a bean invocation. It can be a database call. So let's have a look how actually span looks like, how the object looks like. So a span is basically carries two things. It carries some metadata that are tags. And tags basically say, they hold some context. In this case, the span is for the database query. So the context or the tags in the spans, they say what kind of database it is, what kind of database query was executed. And then there are also logs. Logs are very similar to tags, but in addition to tags, they also carry the timing information. So there is a timestamp associated with logs. The other important data in the span is timing. So we know when the span started. So there is a start timestamp, and there is also the end timestamp or the duration. So we know exactly how long it took to invoke an operation in the system. And the last but not least, there is a span context associated to every span. So there is this trace ID that is unique to the whole transaction. So multiple spans will have this ID. And then there is a span ID, which is a unique ID for a single span. Okay, so tracing is basically just three concepts. Span, which is an invocation in your system. It can be really anything: HTTP invocation, database call, internal method invocation that carries some metadata that help you to understand what kind of invocation it was. And important, all this metadata is the same across all different frameworks and languages. Then there is a trace, which is just a collection of spans. And the trace is basically all the data what has been emitted for a single transaction in a system or a single request in a system as it went through multiple services. And distributed context, it is basically those IDs what we have seen on the previous slide, so the trace ID and the span ID. The distributed context can potentially also hold any other key value information, something like tags. So we have a key, for example, tenant ID and the value, the ID. And this can get also propagated through your environment as the transaction goes through. And it's a very powerful concept because it lets you propagate some metadata very deep into your infrastructure without changing your public APIs. So you would just use the tracing API to create this context, but also access it. You can use it, for example, for resource attribution. Let's say in your first microservice in your environment, you would get the tenant ID, and then on the database layer somewhere very down in your system, you could get that same tenant ID from the tracing distributed context. It might be hard to really understand the distributed context, but it's just the context that is propagated throughout your environment. Okay, so this is everything from the basic concepts, and I would like to give mic to Jayesh, who will do a Hypertrace demo.
Just keep that slide for now.
Okay.
So Hypertrace is a real-time observability platform that helps team make sense of their production requests and trends in their network. And we created Hypertrace at Traceable and we open sourced it. So Hypertrace basically what it does is convert distributed base data into relevant insights for everyone. So the infrastructure teams can identify what services are causing overload in their systems. Then application teams can identify or understand which requests put their service objectives at risk. Or deployment team can know if the new version is causing some problem in their in their whole deployment. So it covers basic use cases for mostly like DevOps teams. Then it basically accepts all major data tracing formats, and which means if you have system instrumented for distributed tracing with Jaeger, Zipkin, or maybe OpenTelemetry, you can try Hypertrace without changing anything in application other than endpoint. Cool. So I will just quickly go ahead with the demo. I will share my screen.
I should stop sharing. Okay.
Yes. I have to find that screen first. Okay, this should ideally work. Yes, cool. Yes. So if you want to try out Hypertrace, or if you want to deploy it, it's very easy. You can just go to github.com/hypertrace and you can clone this repository. There are two different variations here. You can either use the Docker Compose to quickly get started with Hypertrace. You can do Docker Compose up and uh, Hypertrace will be live, and you can send traces to it. So otherwise, if you want to deploy with Kubernetes, we have a Helm setup as well. And in Helm, like you basically, if you want to deploy in EKS, GKE, or AKS, you can go ahead with Helm setup, and it will help you deploy in any Kubernetes environment. Then going to Hypertrace, before that, I will again share the screen and show you the sample application we will be using. Okay. So can okay. So we will be using online boutique sample app, which is created by Google Cloud, and it is a very good application when it comes to distributed tracing, like showing, demoing or showing distributed tracing, because it has multiple services written in multiple languages. It has it basically acts as a online boutique service. So it has cart service, it has ordering service, it has uh, payment service, it has recommendation service, ad service, and all those services make a very good use case for a microservice application, which is instrumental, which is sending data to a distributed tracing platform. So we will just place some orders, and we will see how the data looks like in Hypertrace itself. Going to Hypertrace. Done. Can you add? Okay, cool. When you send some data from there, like when you place some orders, or this request should come to Hypertrace, and you can see your data in Hypertrace. So on the dashboard itself, you will see different metrics, latency metrics, call wait metrics, error metrics, and we'll also see top assets, which will show you things like what are different top endpoints you have, or what different services, what are your top services, or what services are getting most number of requests. Then your top backends will be on your dashboard itself. If you want to look at application flow, which is basically a live dependency diagram, uh, you can switch to application flow, and you can see which service is interacting with which service. And like right now, you can see that front end is talking to most of the services. And now when you go to checkout service is talking to product catalog service, and uh, basically here shipping service is talking to checkout service. So this kind of interactions you can see, and this is live a dependency graph. So if you add any service, or if any other request comes in, it will be in this service graph itself. And when you hover over each of the service, you will see different kind of parameters like P99 latency, P50 latency, error wait, call wait for that particular service. And we identify services and backends automatically. Like you don't have to do anything around it. Like whatever backends you are using, or whatever services you are using, it will be identified automatically and added to relevant dashboards. So these are all of the services, and like basically these are from two different applications, but these are all of the services. When you click on the front end, you will see the service dashboard for front end, and which is mostly all the things any service owner might need. So here you can see the P19 latency, P50 latency, error wait, call wait for front end service. Then there are metrics for latency, errors, and call wait again. And you can see dependency graph for front end itself, like what different endpoints front end is talking to, or APIs front end is talking to, and details for each of the endpoint. So we also have list of top endpoints. So if you are just concerned with the endpoint which is receiving most of the request, you can see the list sorted by number of call rate here. You can even change it to error rate, or P99 latency or P50 latency. Then we have a health radar, and yes, that's all on a service dashboard. So if you want to see all the endpoints your that particular service is talking to, the endpoint tab will give you all the endpoints. So suppose I just want to check the receiver cart endpoint, and this is your endpoint dashboard, which again provides the same detail as service dashboard. And then if I see traces, these are all the traces for that particular endpoint. So if I click on any of the trace, I can see the trace for that endpoint. And here's a complete trace for that particular endpoint we clicked. And then I see if I go and see full trace, this will be it. So how this helps is here you can see how much time each of the call took. I found this on the web. Each of the call took, and suppose like some of the AP like any particular service is taking more time than expected. So you are expecting that processing to be finished in 30 milliseconds or 40 milliseconds, and it's going beyond that. So at that point, you can identify that there's some performance issues, and you can basically go ahead and uh, debug it or see what is causing your service to be your request to be delayed. So there are various functionalities which come with the tracing, and you can utilize most of them with Hypertrace itself. Then there are metrics for your particular endpoint. You can see detailed latency, error and call metrics for your particular endpoint. Again, going back to services. So if you want to see all the traces for your particular service, if you go on traces column, you will see all the traces for your front end service. So if I click on any one of those, I should again see the trace view there. And we basically provide slice and dice on your traces. So if I just want trace with a duration maybe greater than 100 millisecond, I can just search on that and I can get traces with a duration greater than 100 millisecond. If I click on any one of those, I can see the trace view for that particular trace. And here again, you can see that route service is taking route call is maybe taking 254 millisecond, which might be not something which we are not expecting. So we can look into that as an issue. So you can basically use different you can slice and dice on different parameters available here. And again, for each of the service, we have detailed metrics. Going to the backends will be again identified automatically, and you can see here it identified MySQL and Redis as a backend. If I click on Redis, I can see again metrics and graphs for those. I can see traces for Redis and then detailed metrics for Redis. Explorer is where like a major thing lies. Like it's kind of a SQL playground you get out of the box. And again, it provides you different kind of parameters to slice and dice on. So suppose I just want traces with a protocol equal to HTTP. Shoot. Equal to HTTP. So I can get all the traces with the protocol equal to HTTP, which you can, okay, you can just visualizations, which you can see here, all the like here, all the traces have protocol equal to HTTP. And again, I can add more. I can add more parameters and filter on those as well. So it helps you slice and dice on different parameters, and it helps you like it basically helps you drill down to a specific time range or specific thing you are looking for doing debugging or doing just finding out your issue. Then you can also change these metrics. You can add different parameters to your metrics, and even change it to line graph or something. That is also possible. You can change interval for that, and you can do same slicing and dicing on your spans as well, which is also helpful most of the times. And if you go here, if you do service name equal to add service, it will show you all the services microservices, all the spans from ad service specifically. So cool. Yes. So this is basically all about Hypertrace, and this is all it provides as a distributed tracing format, and and helps you make sense of your tracing data. So I will just again stop sharing and share the one and move. Can we get that on screen? I shared my screen again. Once you. Okay. Yes. So these are the top functionalities, or these are the specific features Hypertrace provides on top of open source platforms available there. Like it is also open source, but on top of functionality which Zipchain or Jaeger provides, or OpenTelemetry provides. So here's a like Hypertrace provides you topology. You can view topology of all services and backends in real time. It's scalable for hundreds of microservices. And then Hypertrace provides you dashboards which show services, APIs, and for services, APIs, and backends. It is extensible. You can write your own in-feature for your business use case, and you can use that. It is interoperable between different formats like Jaeger, Zipchain, OpenTelemetry formats, and it comes with a GraphQL, so you can also like utilize the GraphQL functionalities to uh, build build a queries for your particular use case, or it utilizes that functionality in a very good way. So there's also API and trace analytics. So it provides you powerful slice and dice functionality on top of Pino. So that is what we have seen in Explorer itself. Cool. So yes. So if you want to contribute to Hypertrace, or if you want to play around with Hypertrace, you can go to github.com/hypertrace and you can try it out. And if you have any questions around distributed tracing, observability, or even Hypertrace, you can join our community on Slack. We will be happy to answer them. And if you want the slides, you can just scan this QR code and you can get them from here. If you want to learn more about distributed tracing, observability space, and specifically about distributed tracing, you can follow some of these blog posts. They are, especially the first one is really good, and you can learn a lot about distributed tracing from them. Cool. Thank you. And that was all from both of us mostly. Pavol, do you have anything else to share?
That was pretty good. Thank you, Jayesh. Are there any questions? I don't see attendees on the platform, so I'm not sure.
Yeah, I think we had.
I'm not sure where to look for.
Yeah, so I've dropped in a question at the comment section to see if there are any questions. I don't see anything, but let's just wait, or maybe if there are any other questions, then probably I can reach out to you later. We have the contact details, so and then we can take it there. But otherwise, to all of you who are tuned in right now is the chance to post your questions to Jayesh and Pavol. They are live right now if you want it answered. So yeah, it looks like we do not have anything. So I think we are good. So probably you gave like a very crystal clear explanation of distributed tracing. That's the reason why we do not have any other questions, right? So yeah, okay, we see a question. So
there's a question.
does Hypertrace provide AI-enabled? So let me just put that on the screen. So does Hypertrace provide AI-enabled solution to automate the detection of unusual loads?
I don't think there is some AI right now, but we are looking into ways to do to provide to handle some use cases where AI can help you to understand, for example, the baseline of your metrics and so on.
How it differs from Kiali. Like I haven't tried Kiali or searched out. Maybe you know Kiali.
Yeah, I can take this one. I worked in the same team as Kelly at Red Hat back then. And so Kelly is more focused on the service mesh. So Kelly kind of provides two functionalities. It's observability from one.
You are breaking.
Is breaking. Am I breaking? Ransi, can you hear me?
No, yeah, I can hear you, Pavol. I believe the issue is that Jayesh.
Okay, Jayesh, you are breaking because I couldn't hear you well.
Maybe.
Okay, so let's go back to Kelly. So Kelly provides kind of two functionalities. The first one is the observability. It basically displays the data from Prometheus server in your service mesh environment. And the other type of functionality is it allows you to configure your control plane. So in a Kelly UI, you can directly change configuration for what Istio basically exposes, and it provides kind of nice features around that. So it does, for example, validation of those configurations, and it kind of guides you to write your configuration in a correct way. From a tracing perspective, Kelly just exposes what Jaeger kind of provides. So it's able to basically show you just the Gantt chart, what is collected from Jaeger. So I think bottom line is that you could use Kelly with Hypertrace, and Hypertrace would be kind of replacement of Jaeger in your service mesh. There will be some overlap between those two systems because Kelly also shows metrics, but those metrics are different to Hypertrace because those comes from Prometheus. Prometheus is able to emit kind of different set of metrics than what Hypertrace does. The metrics in Hypertrace are only derived from the traces. There is no metrics instrumentation.
Okay. Yeah. Thanks, Paul. I believe you must have already answered this next question.
Yeah, it's basically, so the question is, what is needed to enable Hypertrace? You basically have to instrument your services, your applications. And there are different ways how to do it. In some languages, a little bit easier. In some languages, a little bit harder. So for example, in Java, you don't have to recompile and redeploy application. You can use something like Java agent that will dynamically instrument your app. In some languages like Go, that are statically typed and compiled, you will have to include some libraries at the compile time and recompile and redeploy.
Okay. Yeah. Thanks, Paul. Thank you, Jayesh. I believe we do not have any other questions, so I guess we are good. So thanks again for your wonderful session on distributed tracing. It was a pleasure to host both of you. And the beauty with the virtual meetup is doesn't matter where you are, and that's the reason why we are all connected. But at the same time, it's sort of like a bit overwhelming. And hopefully, this is the last meetup, the virtual meetup for this year, and we get to more saner ways in the next year, hopefully, with the physical meetup and other one. So with that, it's a wrap. Thank you all for joining in. Stay home, stay safe, and save lives. Bye, everyone.